So questions? All right, let's talk about synchronizing in Java, and let's run some sample code.
You're muted.
I am muted. Thank you. All right, questions? All right, so synchronizing in Java. So we talked the other day about how to create threads in Java to run multiple processes, and we worked through some examples of things that can go wrong. The example of two ATMs connected to a bank, and how if they access the same information at the same time, you can get unexpected results. So we wanted some way to make read, modify, write operations atomic, so they couldn't be interrupted. And we talked a little about deadlock and live lock and resource contention and so on. So pretty simple mechanism in Java for dealing with some of that, which is Java gives us a way to basically have kind of an atomic flag of sorts, a way to execute some code and say, hey, while I'm running this code, nobody else is allowed to execute this code. So to put an exclusive access on a method. And so let's look at some sample code. And so let's see. All right, I'm gonna have to find it. Yeah, you're definitely gonna have to talk to me about that, because it's kind of late in the game. But send me an email, let me know the details, and we'll go from there. All right. So I've written a couple of classes, and the idea here is we're going to simulate a voting system where people are using different voting machines and votes are being tallied in a central location, and we're gonna have a runoff for Emperor of the Galaxy between Yoda and Darth Vader. Right, why not? Because that's what most elections come down to anyway. So I've got a pair of classes, sleep class and voter class. Sleep class is just a delay algorithm, right? So inside a thread, there's a method called sleep. It's a static method. And if you just say sleep t, let's look at the page for that. So sleep is a static method. And it takes a number of milliseconds, and it waits that long, right? And it can throw an exception, so we have to put it inside a try-catch block, because it can be interrupted. There's a way for another process to come along and say, stop sleeping, and it responds to that by throwing an interrupt. So sleep class is just a class that contains a method named delay. You can tell it how many milliseconds you want to sleep. It'll put itself to sleep for that long. All right, so that's just a delay function. So our main action is happening inside voterTest.java. So here's the setup. We have a central vote recorder, right, which is an object of type vote recorder, and we have three voting machines, objects of type voting machine. And each voting machine is constructed with an ID telling it, which machine it is, and also the vote recorder, so that the machine can tally votes and send them into the central repository. Alright, so here's the vote recorder. Right, it records votes for Darth Vader and for Yoda. And these are proper nouns, so I excuse myself for starting with an uppercase letter, even though we don't normally do that for objects, right? So when we construct the vote recorder, we start with both votes equal to 0, right? That's the way it works. And then I have a pair of accessors for reading the number of votes that Darth Vader and Yoda have, and a pair of mutators for setting the number of votes that Darth Vader and Yoda have. And I also have a show votes method that just shows me the current tally so that, you know, news networks can show the running updates on TV. And so here's what the voting machine looks like. Each voting machine is going to be its own thread, so they're going to run asynchronously. And when you construct the voting machine, I'll record the ID of the machine and the ID of the vote recorder. So VR and ID. And the run method is going to simulate people going to the polls casting votes. Alright? And so Yoda's supporters, you know, wake up first thing in the morning, they do some Tai Chi or whatever, and then they go and they vote. And so, in this setup, each machine, 150 people are going to come and vote for Yoda, right? So for each of these 150 people, we do the following. We read the current vote count. There's a little bit of a delay there, right, while they meditate or something at the poll. And then they increment the vote count, and they set that back in the vote recorder. And then they're going to just show, you know, what the current tally is, and that's going to run 150 times. And then after that, Darth Vader supporters will show up. They roll out of bed a little later in the day. And there's only 100 Darth Vader supporters in each district. So those 100 will show up. They'll read the vote total. They'll add 1 to it. And they'll write that back in. And we'll see what the vote total is at that point. Alright? So it's a very simple setup. Right? We have 3 voting machines. At each machine, 150 people will cast votes for Yoda, and then 100 people will cast votes for Darth Vader. Right? Super straightforward. And our random delay just waits, you know, from 0 to 5 milliseconds in between each vote. Alright, so let's try this without threads. So let's just call the run method on these 3 machines. And make sure nothing weird happened. Right? And no surprises here. Darth Vader loses, Yoda becomes Emperor. I don't think Yoda would accept the title, but, you know. And if you look at what happened, it's exactly what the code says it should do. Voting machine 1, Yoda supporters showed up. Yoda's votes went from 1 up to 150. And then at that point, Darth Vader's votes started coming in, and those went from 1 up to 100. And that was the end of voting machine 1. And then voting machine 2 started, and 150 votes came in for Yoda, so Yoda got up to 300. And then Darth Vader supporters came in, another 100 votes, so that brought it up to 200 to 300. And then voting machine 3, another 150 for Yoda, brings it up to 200 to 450. And then Darth Vader shows up, gets another 100 votes. And we end up with our final tally, 300 for Darth Vader, 450 for Yoda. So no surprise there. The interesting thing happens when we run these things as threads. So now all 3 voting machines will be running simultaneously. And in theory, that should not affect anything. each machine still has 100 votes for Darth, 150 for Yoda. So the behavior should be exactly the same. But now when we run it, guess what? Yoda loses. Darth Vader becomes Emperor. Evil laugh.
Because he is weight or something.
Yeah, so why does this happen? So
Everyone finishes first, and then it kills the whole process.
Sort of. But I mean, this will be different every time that we run it. Except Darth Vader consistently gets 300 votes. Yoda got up to 170 there. But Yoda's having a hard time breaking 200, you know. Didn't even get credit for 150 from one machine. Right? So this is pretty bleak.
Is the reason that it's one of them's winning and one of them, or why Yoda's always losing, is because the reason it's different every time is because there's the sleep random.
Yeah.
And then the reason why he's losing is because they're sleeping, and whichever one finishes first kills the process.
Well, basically, although it doesn't kill the process, but this is this read modify write, and by putting that delay in there, right? The fact that this is not atomic becomes more critical because there's more time between the read and the write, and there's a better chance that something else is going to come along in between here. Remember, our synchronization problems happen when we have this read modify write, and it ends up not being atomic. It gets split in the middle. So if I put in a delay of 5 milliseconds between the read and the write, it's a really good chance that someone else is going to come along and try to make a vote here. In particular, on one of the other machines, one of Darth Vader's supporters might come in, and if they manage to do a read modify write while I'm sitting in here, they will obliterate that vote for Yoda. And so it's this sneaky little, well, not very sneaky, but you know, it was this random delay that I put in here that that's causing the main issue. Now if I take that out, well, things work better, but if I put in enough threads and I ran this far enough, we would start to see some corruption. Maybe. Let's try it. Let's do 15,000 votes for Yoda. And 14,950 votes for Darth Vader. Let's see if we can still tip the election. I haven't tried this before. I don't know why. Okay. That's working surprisingly well. Alright.
Sorry, what did you do to make that work?
I was trying to break it without having that random delay, and it's apparently a little harder to break than I thought. And I thought maybe if we had more votes.
Seems to me like the random delay is what's making it all on, right?
Yeah, I was hoping I could break it without having that random delay. Let me try one more. Oh, there we go. So that time Yoda lost a vote. And I don't have that random delay in there anymore. Right, so I've commented that out. But Yoda still lost a vote. So it's working pretty well, but not entirely 100% reliable. Here Yoda just lost 2 votes. right? So I put the random delay in there because it makes it really obvious that there's a potential resource contention here, a potential synchronization issue. But even without that delay, it can still happen. And the more threads we have, and the longer it takes to do a read, modify, write, the more likely that that this is going to be an issue. So this is subtle, right? And this particular version of the code, I might have written this and tested it and said, hey, it works great, right? And then I roll it out. This is why open source is really good, by the way, like, for voting machines and self-driving cars and stuff like that. But anyway, so there's an issue here, right? And the issue is, even without the delay, we're doing a read, a modify, and a write. It's not atomic. All right, so let me put this delay back in here. And get the extreme imbalance. Poor Yoda's really getting hammered now, right? So how do we fix this? And the goal is, when we're beginning to do this process, we don't want another thread to be doing this process, or even this process. Right? So this was the example with the ATM on Monday. We read the current balance, we adjusted it, we wrote the current balance. Well, at this point, we've decided what the new vote will be. But if at that point another machine kicks in and a whole bunch of votes come in, we're going to erase those because we've got an old, stale current vote total that we're about to update in the main balance. All right, so how do we fix this? There's a keyword, synchronized. And we can put the keyword synchronized around a block of text. And when we do that, the code in that block can only be run by one thread. And if another thread tries to run that same block of code while another thread is running it, that second thread will block. It'll wait. And it won't be able to start executing it until the thing that's currently running it releases it. So the structure for this is the keyword synchronized, parentheses, and we need to have some kind of flag in here. And then we list a block of text inside curly brackets, and everything inside that block is now restricted to whoever has access to that flag. And that flag is like a mutex, so if one person has that flag, nobody else can get it. And the process of getting that flag, that's synchronized. That's not a situation where, two threads might try to do it at the same time and things get confused. So that's being managed by the JVM. So what is this flag? It's any object that we want, but it's got to be a unique object that every thread has access to. Right? If I pick up one flag, so here's the deal. When I want to run this piece of code, I'm going to try to pick up this flag and hold it up over my head. If anybody else has the flag, I can't pick it up. I have to wait. But if the flag's available, I'm going to pick it up, hold it over my head. And any other thread that tries to run this code is going to, see that I've got the flag, they're going to wait. When I finish executing this block of code, I'll put the flag down, and now another thread can pick it up and hold it. Right? So it's flagging, right? Like a railroad flag. It's telling the other threads, hey, you're not allowed to run yet. And I can have multiple flags. I can have a red flag, a blue flag, a green flag, right? So my flag is just an object. And it can be any object, but it's got to be an object that every thread has access to. So I'm just going to use the simplest option here. Every thread has access to the same object VR. That's the voting machine. When I construct my threads, I always pass R, right? That's a vote recorder. that I'm passing, and each machine is saving in this object called VR. So in the constructor, the second argument, the vote recorder, that gets saved in VR. So every thread has access to VR. That's going to be the flag I use. It could be anything, but it's got to be, you know, every thread has to use the same object. So around here, I've got my random delay. I'm just going to synchronize this part. So I'm going to say synchronized VR curly bracket. And I'm just going to close my synchronized block here. All right, so I'm going to get exclusive access to this chunk of code. Once I have that, I'll read the current vote total, wait a little bit, update the vote total, write it back. And then this curly bracket that ends the synchronized block, now another thread is allowed to start executing this code. And so everything in here can only be done by one thread at a time. And that will prevent this synchronization issue. Now I could put, you know, this whole run method inside a synchronized block. Well, then I'm not running in parallel anymore. If I do that, whichever process starts executing run first is the only thread that's running, and the other threads are waiting. So just like try-catch blocks, we want to keep our synchronized blocks as small as possible. If I put this entire loop inside my synchronized block, my whole 150 iterations are going to run before another thread can start its loop. So you got to be a little tactical about where you put these. But the part that I want to make atomic is this read, modify, write. Alright, I'll do the same thing for Darth, because, you know, it's a fair election. So we'll synchronize on that. Now, I'm doing something I don't really need to do. I'm not going to allow votes for Darth to happen while someone's voting for Yoda, and vice versa. That's kind of overkill, right? There's nothing. Say again?
Voting for the same person.
Say again?
So you only want that if they're both voting for the
Right,
same person?
right. Yeah, because reading Darth's count, updating that, and writing it back should not affect the proper execution of this code, which reads Yoda's total, increments it, writes it back. But if there was, you know, something else going on in the machine where it was, you know, tallying the total number of votes or something, you might only want one thread at a time interacting with the vote machine in this way. So, you know, I could have different flags. I could pass another flag to the voting machines, and they could use that in here and here. I could put the show votes inside the synchronized block, but I don't need to, right? Showing the votes is not going to affect whether or not this executes correctly. So keeping the synchronized block as small as possible. So with that one change, we can run this, and it's a fair election. Although it's very, yeah.
If you were to, instead of setting the vote by going get vote and then set vote by incrementing it, if you were just to have a function that was just called increment vote by a certain number, could you then not have to synchronize them?
I think you can still get into trouble, because the increment vote method would be potentially being run by two threads at the same time. And so even though it's this code inside the vote recorder, right? If that block of code runs twice simultaneously, you could still have this contention where, you know, one thread, because ultimately something in there is you know, going to say vote equals vote plus 1. Well, it's got to take the current value of vote, increment it, write it back in. And so it would be rarer that you would see, you know, two of those things happen in the same way that creates that ATM type glitch, but it could still happen.
Did ATM used to have this glitch? I didn't know if you.
No, this was the example from Monday that we did.
Oh, I see.
Yeah.
Yeah, but I'm sure when ATM first came out, it seems like something that I'm sure someone forgot to disable being able to get into an ATM.
Yeah, hopefully not. I don't know if that happened or not. Hopefully not, but yeah, maybe. And we won't even talk about rounding the pennies, right?
A couple people have made a lot of money like that, right?
Yeah, well, that's the whole Office Space thing, right?
Yeah, Office Space.
Yeah.
I love that one.
Um, I'm a little disturbed right now because this did not do what it was supposed to do. And I don't know why that is, and I also don't know why why Yoda's getting all of their votes before Darth starts getting any votes. Oh no, not strictly speaking. It's just a timing thing, but they are running in parallel. All right, so that's how you can synchronize sections of code. And the harder part is knowing, when do I need to do this? Now, if I do this all the time, right, I lose my parallelism. And you can certainly avoid deadlocks by only having one thread do anything at a time, but that's not a great solution, right? So, we touched on this briefly before. When you look at the documentation for different methods, you'll sometimes see a comment saying something like, this implementation is not synchronized, right? This is warning you that, for example, in the linked list class, there's no synchronization being done for you. And so if I have a linked list and I have two threads and they can both be modifying that linked list at the same time, I could have a problem. Right? A same kind of problem. Each one wants to add something to the end of the list. It may be that one of the threads, the thing it adds, gets lost, right? Because it decides where to put it, and it starts to put it in there and adjust the previous node's pointer. But then this other thread has already decided what the previous node was, and after the first thread points to that new last node, the second thread does the same thing. And that node added by the first thread is lost. And so if you're doing plain old linked lists, right, uppercase L linked lists in Java, and you have threads, you probably need to synchronize some part of it yourself. And by synchronizing on some object, that naturally encapsulates the list, etc., etc. So, so that's just something to be aware of.
I got a question.
Yeah.
So when is the best time to use synchronized? Is it only when you read and write, or read and then modify it, but then do the write afterwards, or is it when synchronizing all three, in all three?
So for a read, modify, write, I really need to start my lock when I'm doing the read and the modify and the write, and really capture all three of those. If I do my read here and then I synchronize, well, it's possible that between the time that I've read the current total and I got the exclusive lock, that another process just finished updating that total, and so the current vote should be higher than I have. But if I use my current vote that I read, I'm erasing that other thread's vote. And if I synchronize all of this but not the write, I could come up with a vote, tally another count. Now I'm ready to record the new vote. But in between that and the writing of that total, another thread comes in and casts 50 votes for Yoda. And now I come back and I say, hey, let's set the total to current vote. Well, I've just erased those 50 votes. And in thinking about this, right, you have to kind of imagine, Alice in Wonderland type versions of reality, where, maybe between the execution of this statement and this statement, a million things happen in another thread. And that would not typically happen, but if something can go wrong in that scenario, something can go wrong in the real world scenario, where maybe one or two things can happen in another thread. So yeah, for this example, I need to synchronize the entire, read the total, update it, and write it back. But in general, there's no hard and fast rule for what needs to be synchronized. You really need to kind of think about what the world looks like with however many threads you have running, doing whatever they're doing, and ask yourself, can there be an issue like this? And it's tricky. I don't know of a systematic way to answer that question of what should be synchronized. So it's experience and practice and trial and error and trial by fire sometimes.
Yeah, I can see how this can be hard to implement. Is there a reason why you have the random delay method inside the Yoda votes versus Darth Vader votes?
Yeah, because I wanted to break it. Actually, if I put a random delay inside both, so let's not synchronize it. If I put a random delay inside both, it should certainly break, but I don't know who's going to win. Right, so they both kind of lose votes in that case. The longer the read, modify, write takes, the more likely you are to lose votes in this case. So that was just for dramatic effect of having an opposite outcome from what we were expecting.
Do you synchronize without the random delay?
Can you synchronize without the random delay?
Yeah, because when it's random delay is the reason why that Darth Vader votes came in later.
Yeah, so we took out the random delay and we saw that it was harder to lose votes, but that occasionally a few votes did get lost. That was those examples where we ran. That's when we switched to 6 threads, and there were a few cases where Yoda would lose 1 or 2 votes in the end of it all. I don't think I can scroll back to it. So not going to be an issue for PA5. But something to keep in mind. And like I say, in future courses, you'll work with this a lot, and do things where if you don't synchronize properly, you will definitely get wacky results. And so you'll have future assignments in other classes where you're playing with synchronization of threads. And different systems have different ways to do this. So I don't remember what they're called. But there's okay, so yeah, pthread. So pthreads are a way to manage threads in Unix from C programs, and it's a much more complex but more detailed system. But I mean, managing processes, creating processes at all in C is a much more kind of low-level proposition. So there's a whole class of not a class, but a whole set of functions around pthreads that you can use to create threads from a C program that you can synchronize and control access to with different flags and such. And that gets complex pretty quickly. All right. Other questions on this whole synchronization business?
Can you make more examples on synchronization? Because I guess I'm just not fully understanding of when or where it is best to put synchronization.
So suppose you have two threads that are manipulating a linked list. And one thread is getting input from a user and adding it to the end of a linked list. And another thread is getting input from a user and deleting things from a linked list. Right? So one person's typing in, new information, and each name they type in gets added to the end of a linked list, and another person is typing in deletions, and so they type in a name and they find that name in the linked list and delete it. Right? That's an operation where if you don't synchronize correctly, you could possibly corrupt your linked list, because here's Bob, here's Sally, here's Nick, here's Carol. And let's say someone wants to add Izad, and someone wants to delete Nick. Well, or let's delete Carol. So, what does your delete code do for a linked list? Well, move down the list, have your temp pointer until you get to Carol. So here's my previous, and here's my next. And I'm going to say, previous, next, equals null. And that's going to remove Carol. Well, somebody else wants to add Izad, and so they're moving through until they get to the end of the list, and they've got, some pointer temp, and they're going to say temp next equals Izad. Well, if they've already gotten to the point where they've decided this is the last node of the list, and they're about to do this, but at this point I say, Carol's the last node of the list, so to delete Carol I'm just going to set Nick next to be null, right? I get rid of this arrow and point to null, and I'm done. And now this process says, okay, well, let's have this thing point to Izad, and it's done. Well, what does the list look like? It looks like Bob, Sally, Nick, and Carol's not in there anymore because it was deleted, but Izad didn't get added because he got added to the end of a node that was in the process of being deleted. And so you run this code, and your code looks perfect, but once in a while when you do this add routine doesn't seem to work. And it happens, once every 1,000 cases. So what I would want to do is at the beginning of the code that's going to, move through and find this node and delete it, I would say, okay, let's synchronize that on a shared object. And the code that's going to add, which is going to move down, find the last node of the list, and then add something, I would synchronize that on the same object. And now if I begin doing my delete operation, I have to wait before I do the add operation.
So basically, the best time to do it is when you're the best time to do it is when you're in a read, modify, write.
Effectively, yeah.
Basically, because otherwise, if you have one program reading while the other program is running, that's probably not go well together. So when you have two synchronized blocks together, do they both get executed one at a time, or you mentioned about holding up a flag. I'm assuming that it get run one at a time, and then wait for the other synchronized block to run, correct?
Yeah. So here's a thread that's running, and here's another thread that's running. And if there's no synchronization happening, these run, kind of independently of each other. If I have some block in here that's synchronized and some block in here that's synchronized, right, here's what can happen. These threads start, they might start at the same time at different times, right? Whichever one gets to this block first, they get to continue executing. If another thread gets to the start of that block, it stops. And this thread continues until it frees that object, that flag, And then at that point, another thread that was waiting for it can continue. And if this is continuing down here while this one's coming down and this gets to the start of this synchronized block, this thread will wait while this continues to run. When it leaves the synchronized block, now this one can enter it. And if you have multiple threads, you know, that each try to execute that set of code somewhere, you might have one thread that's executing that, and you might have 3 threads sitting here waiting to enter that synchronized block of code. And once this thread leaves, one of these will be allowed to enter. Which one, we don't know.
Yeah, I have a question about that. Do you make different synchronized blocks for like different objects?
Mm-hmm.
I'm just curious about that.
Yeah, so if I synchronize on object 1 and I synchronize on object 2, those 2 blocks of code are free to run at the same time. Right? But any blocks of code synchronized on object 1, only one of those can be executing at a time. And so object 1 is kind of like, you know, the white flag. Only one process can grab that white flag at a time. Object 2 might be a blue flag. And if something's synchronized on object 2, it can run at the same time that something as synchronized on object 1 is running. So typically, you know, you might have multiple threads running that have multiple sections of code that need to be synchronized, need to be set up so that only one of those blocks is executing at a time. But there might be different sections of these blocks of code that are independent of each other. So we can put an argument in the synchronized keyword, and that's basically the flag. This is fun stuff to play with, by the way, right? It takes, you know, a couple of lines of code to create a thread. And you know, it's not bad to make, you know, 10 or 20 threads and have them run simultaneously. You don't want to make a loop that creates an infinite number of threads because your JVM will crash. But, you know, to create, you know, 10 or 20 threads, not a big deal. And mess around with this. See if you can come up with your own examples where not synchronizing threads causes some kind of behavior like this. And you can always, you know, try to extend a read, modify, write operation to sort of artificially inflate the chances of this kind of misbehavior. And then you can play around with synchronizing to resolve that. All right, other questions?
Quick question.
Yeah.
Are we gonna have ODPs about threads?
I don't think so. I
Pretty hard to make one for that one.
Yeah, I thought about it, and I could do some nominal ones, but it would be hard to really kind of do something that kind of gets you into the idea of a thread as opposed to just some plain old code wrapped in a thread wrapper. But you know. Right, so I mean, we had some pretty short code from Monday, right? This is up on the server under thread-Monday. Construct some threads and start them, and the threads just, you know, printed out some information in a loop. And you can see these things fighting with one another when you run this. The outputs are being intermingled. And so, well, let's see what we can do here.
That int ID is something that's just given, right?
Yeah, that was passed to the constructor.
That's not something you come up with, though, right? That's just something that's made.
So this was an example where I wanted to have 3 threads. This was our first introduction to threads. So I just wanted to be able to identify these. So let's change this. Let's have each thread print out 10 values, right? So from 0 through 9. And let's do that in an infinite loop. And so each thread will forever print out the number 0 through 9, followed by a message saying that it's done. And so, you know, we've got chaos going on here. But let's see if I can get what I'm looking for. So, for example, thread 3, you know, started to run here, and after that, thread 1 said it was done. And up here, thread 2 started, thread 1 got through steps 7, 8, 9, and then said it was done. And then thread 1 ran to completion, thread 3 ran to completion. Thread 1 announced it was done, and thread 2 is still waiting to continue from its, 2:0. It doesn't really kick in until down here. And then it goes 2, 1, 2, 3, 4, and then it gets superseded by other threads, and then eventually it comes out with 2, 5, 6, 7, 8, 9, and then eventually it says it's done. So let's synchronize this. Let's try to make sure that each thread gets to go from 0 through 9 and say it's done without interruption. And so I'm going to synchronize on some kind of object. I'm not going to synchronize the entire run method because the run is an infinite loop, but this inner loop, I'm going to do the following. I'm going to synchronize on some flag.
Can you remember what goes inside the flag again?
Yeah, we're going to have to figure that out. So the flag is the flag, right? It can be any object that we want to use as a flag. But let me show you something that will not work. Right, if I just make flag a string, oh, that was unexpected. Let's not use a null flag. Right? That's working better than it should. Oh, okay, that was a bad example. Okay, forget I did that. Alright, let me just show you the way to do it. Forget the fact that that worked. That shouldn't have worked. But it worked in the same way that sometimes using double equal signs to compare strings works. Because quote haha, it's using the same object, even though it's being set up in 3 different classes. So forget what I just did. Erase the last like 45 seconds from your memory. Let's just do this. Let's make a flag. I don't know. Doesn't matter what we call it. We can just make it a string. But I'm going to pass this to to my constructors. So up here in my main method, I'll have this is just some object. I'm going to pass that to my threads. And then inside my constructor, so I'll have a string flag. Right, so I'll take the arguments that's passed to the constructor, and I'll save it in this flag, and then I'll use that as my synchronization flag. And I'll spell it right. All right, so this should be nicely synchronized. So each thread, once it begins to execute, is allowed to execute all the way through the end of the for loop and the point where it says it's done, without another thread interrupting it. All right, if I want to show you an example where this breaks, let's try this. Let's have an integer bad flag, and let's try to synchronize on bad flag. It's not my day for breaking code. Alright, I can't break it. But anyway, take...
You're so good at programming, you just can't break code at all.
I guess, yeah. So make sure that the object that you synchronize on is the same object for every thread you're trying to synchronize. And I'm trying to come up with an example off the top of my head where they're synchronizing on different objects, and I'm failing for some reason. But make sure, you know, you have, in this case, a single object, right? This flag called, this string called flag, and I pass that same object to all three threads, and each of those threads takes that same object and stores it up here, and so on. And so we've synchronized this so that that these threads begin and then end, as opposed to this kind of behavior where they're interfering with each other. All right, any other questions on that? Hey. We can still do state machines. All right, let's do a 5-minute break. Come back, we'll start talking about PA5, and then we'll start talking about networking. So let's do a break here. Let's come back in just about 5 minutes. All right, so I'll see you in a few.
Cal, you there?
I am here.
Hey, how did you do your reset in PA3? You mentioned you just recalled your initialize function in some way, but you're
Yeah.
gonna do something like that, but it's wanting some sort of special class, or it needs a graphics configuration. Oh wait,
Do you mean PA4?
yeah, but
I didn't really do anything super fancy or special. I initially had all my initialization stuff in the constructor, although I had a separate initialization function for the game board itself to be created when all the user inputs were taken. But all the frame stuff, like the input boxes and the start button and the window itself, that was all handled in the frame constructor. But since I couldn't recall the constructor without creating a new window object, I just moved all that constructor stuff to a new initialize function and called that initialize function from the constructor. And then whenever I want to reset the entire game, the entire board, whatever, I just recall that new initialize function. And
How much did you put in that initialize function? Did you set your content?
Quite a lot. There's quite a lot in there. All the member variables in the frame class are declared, they're declared but not initialized. And then in the initialize function, it assigns new objects to those reference variables. So for each one, it has to like create a new object and set the values of those objects, like the position and color and stuff. And then adding mouse event handlers and what to do if the mouse is clicked and stuff. So it's quite large. But then it sort of just runs in its own thread in the background once it's all done.
Oh, okay. Alright, thanks. I'm trying to do something similar, but every time I click the button, it just stops all the code running and just freezes the window. So,
Alright, I'm late. But I'm back.
So I was talking to somebody on the Discord, and they mentioned something about talking about singletons, which are kind of like global variables that are used a bunch. Can you talk about that?
What's the term again?
Singletons.
Singletons. I'm not familiar with the term outside of set theory.
Okay. Because I've been using a lot of global variables for PA4 for like keeping score and mostly for players' names and so on. But didn't you say that you like trying to minimize using global variables or being careful with them?
Well, so the term global variable gets a little confusing with objects. So for example, if you define a class, something, and we have methods, and so on, we can define objects up here. We can have, integer score, car, initial 1, initial 2, and so on. And those, we can think of them as being global inside this class, in the sense that every method in this class has access to these variables. So the usual sense of global in a C program, we put a variable declaration in the beginning outside of a function, and every function can access that. So these are global inside the class, and that's not bad, right? The whole idea of making a class is to encapsulate data and code together. And so the data that logically belongs with these methods, this set of code, should be part of the class. And if there's, data that's going to be used by multiple methods in here, we don't always have the option of passing that data. For example, in a binary tree, we might have, a node called root. And in somebody using this class, they might make, tree t equals new tree. And if they want to print the tree, they might say t.print. Well, they can't say t.print parentheses root, right? They can't send this variable to the print method because the print method is inside the object itself. But if we only define this root inside the constructor, then the print method wouldn't be able to access it. So, I think kind of inherently as humans, we like global variables. And we try to pass values to functions in C because it makes the code cleaner and less error prone and so on. But when we get to an object, right, or creating a class, it's very natural to have effectively global variables in there that are shared by the different methods inside the class definition. But we can still have globals where we really don't need to have globals, right? So for example, our first drawing program, when you click the mouse, I wanted to save the XY coordinates of that mouse click. And then I wanted to call repaint, and I wanted paint to use those saved XY coordinates. So absolutely, those XY coordinates needed to be declared basically as globals inside that JPanel class, right, the myPanel, so that the paint method could get to those same things that the rectangle save method had saved. Where you can start to get into trouble, though, is when you start to do things with variables like this that you really could be doing better with, say, a function. Or if you begin to yeah, it's a little hard to describe, but if I see it, I can point it out to you. In the context of PA4, my mention of globals versus non-globals was meant to be more along the lines of thinking of ways that you can minimize how many ways you store the same piece of information. For example, whose turn is it? Well, I can have a Boolean called player 1 turn. And I set it true when it's player 1 turns. I set it false when it's player 2's turn. I'm also going to have something on my display that says, whose turn is it? and it might say, you know, Nick's turn, and then when it becomes someone else's turn, it'll say this other person's turn, and so on. I have that information about whose turn it is stored in two different places. It's stored in this Boolean, and it's stored in this label. Potentially, I might not want to do this, but potentially I could use this label as my Boolean flag, right? And I could say, hey, if this label is set to Nick, it's Nick's turn. If it's set to Joe, it's Joe's turn. Or I could write a method called, you know, player1 turn that returns a Boolean and looks at this and checks to see if the name in the label matches the name that's been stored for player 1. And where is the name for player 1 stored? Well, maybe it's stored in a string, or maybe it's stored in that text field that the person typed into before they hit the start button. And so now I don't need any global variables. I could make a method called is it player 1's turn, and it would simply compare the name in the field where I'm showing whose turn it is to the name in that first field, that first text box. And if they match, I'll return true. If they don't match, I'll return false. So it's not like globals are evil, right? The way we like to say they are in C. But give some thought to where you want to store information. Do you want a variable that stores the score? Or do you want a method called score that counts the number of boxes owned by each person? Do you want a variable called game done, or do you want a method that looks to see if all boxes have been filled in, and if they have, it returns true, otherwise it returns false? And you can do it either way, but if you have a variable that reproduces information that's stored somewhere else, that's the same information stored somewhere else, you need to keep those in sync. And so if somebody says, like, you know, restart the game halfway through, well, now you have to clear all the boxes, and you have to clear the score, and you have to reset the current player to player 1, and you have to update your current player flag, and so on and so forth. You can do it. It's just different ways to think about it. So I think that was my main commentary on globals with respect to PA4. But yeah, definitely don't shy away in general from having, you know, these kinds of things declared here. You absolutely need to have things declared like that.
It kind of depends on how you lay out your code, right?
Yeah, absolutely.
I've always been a big fan of making methods, but the problem about that is, like, scoping is the biggest issue for me.
Okay. Methods are fairly forgiving scope-wise, because I can give, you know, the whole world access to a method, and inside the method I can decide what I want to do. And so I'm a little more comfortable having a public method than having a public variable where somebody could come in, you know, from outside and just change a variable, and maybe, you know, maybe they change this integer score and they don't update the label that's on my GUI next to the word score, and, you know, you do something in a function somewhere that sets the score back to 0, but this score still says, you know, 16 to 20. And I'm not talking about malicious users here. I'm talking about, you know, things that we're doing in methods where we're making a mistake. If I make the score private, right, I'm not going to inadvertently have some code that does that. If I always update the score through an update score method, well, in that update score method, I'll set this variable, I'll reset this, and so on and so forth. These are all issues that are pretty trivial, but if you imagine, you know, a program with a few million lines of code being developed by a team of 100 programmers, then these kinds of missteps don't seem so far-fetched. All right. Let's look at PA5. So no big surprise here, right? PA5 is as promised the networked version of PA4, so we can call this NetDot. And this is basically, the same game of dots, but it's still two people playing, but instead of sharing a mouse, right, each person is on their own machine. Each person sees their copy of the game. Each person has their own mouse and keyboard and can do whatever they're supposed to do in playing the game. So details up front, right? So write this in Java. Use swing for your GUIs. I suggest working in Eclipse because it does a lot of the boilerplate coding for you for creating frames and placing components and so on.
Question?
Yeah.
Can we reuse the PA4 code that got done?
Definitely reuse the PA4 code.
Okay.
That's part of the goal here, is to not have to rewrite everything, but to just sort of add a layer on top of what you've already done. So yeah, rip off your own code for sure, and extend it. So you'll want your code to work as a standalone set of classes, so don't do anything weird in there, right? And same as before, it's a group project if you want, 3 people per group maximum. You can stick with the same groups, or if you want to start a separate group, or if you decide you want to work alone, it's totally up to you, right? So no requirements one way or another. Just make sure, I would say, if you've been working on PA4 with some other people, and you decide you're going to do PA5 by yourself, you probably want to just mention it to them, right? And say, hey, I'm going rogue, just so people aren't counting on you and stuff. If you're in a group, coordinate who's going to turn in their tar file to Canvas. I'll grade whichever one I happen to come across first. And make sure each group member's full name is included in the comment right at the very top of each .java file, same as PA4. And so let me show you a sample of what this might look like. So I implemented this as the same main class, netDot instead of dot, JPanel class, a box class, and then one additional class which is handling the networked communications and is using threads. So I can compile this, and when I run this, I get a window that looks as follows, right? It's the same game of dots, but there's some other business here. There's a pair of radio buttons to choose. Do I want to be the server or the client? The server is player 1, the client is player 2. And you don't get to specify both names. If I'm going to be the server, I can specify player 1's name. If I'm going to be the client, I can specify player 2's name. And I have to say what machine is the client running on. If you're running this on one machine, you can use the word localhost for the name of your local machine. Yeah, I'll come back to that in a sec. Thank you. Remind me if I forget. We're going to have 2 instances of this running. So, one way to do that is just come in here and just run another instance of Java. Let me move that out of the way. So now I've got 2 of these windows running. All right. So this is a client-server model. We're going to talk about client-server. And one of these instances of the game is going to be the server. The other is going to be the client. All right. So the server is the thing that has to start running first. And by default, that's going to be player 1. So I'm just going to click this box. I'm going to say this is going to be the server. And I'm going to pick player 1, and this will be, Nick. and you need to start the server before the other player can connect to it. So I'm going to hit the start button, and now I'm waiting for connections to come in from another player. So this player is going to be the client, and this will be player 2, and I don't know, we'll just call him Joe Bob. And I'm going to connect to a server on my local machine, so I can use localhost. If you're doing this on a network at home, you know, you could put in an IP address for a different machine, 192.168.0.5. Or, you know, if your firewall is set up to allow such things, I could connect to, you know, a machine on somebody else's network. So we'll just use localhost for now. So I'm going to go ahead and say connect. Okay, so right now, you know, there's no score showing, there's no player name entered here, and so on. I can change my name if I want. Once the client says connect, things get locked in. So it says current turn is player 1, that's Nick, and there's no score yet. If player 2 tries to move, it's not going to do anything. And I'm getting debug messages in my window saying it's not your turn. Right? So player 1 moves. So I'm going to move right here. This is the best pair of dots in the whole game. As soon as I click on that, both boards update. So I clicked here to draw a line, but Joe Bob saw a line appear. The score showed up as, you know, 0-0, and now both boards are showing that it's Joe Bob's turn. And so if I try to move, nothing's going to happen. So player 2 can draw a line right there. Both boards reflected, both boards switch to player 1. So here's Nick's move, here's Joe's move, here's Nick's move, here's Joe's move. Alright, so now I'm going to go right here. And on both screens, right, that line gets filled in, the initial gets filled in, the score gets updated, and it remains Nick's move. So I can move again. I'll go right here. Same thing. Both boards completed the box, drew an N. Nick updated to 2, and it's still Nick's turn. I'll go right here. Both boards switch to player 2's turn. Player 2 can go here. Player 2 can go here. Gets their initial. Score updates 2-1. It's still player 2's turn, and so on. So these two games have to stay in sync. Right? And the goal is that you know, two people are playing, but they're on separate machines. But they both see exactly the same thing, and the state of the game is consistent.
Sometimes you're synchronizing the paint method as well as the score method, correct?
So in here, when I say synchronized, I'm not talking about the synchronized keyword. It was a bad choice of words on my part. But
Okay.
these two things are moving in lockstep. So when something updates here, it should update there, and vice versa. But yeah, it's not actually like Java synchronized. All right, and then there's a quit button, and if somebody hits the quit button, both games end and we're done. And, you know, I've got lots of debug messages coming out on mine showing me where mouse clicks occur and what the row column is, and when I'm receiving messages from the other side, and so on and so forth. All right. So there was a question in chat about making tar files for PA4 and 5, because PA4 and 5 are in Eclipse, which is different. The trickiest part is probably locating where your source files are, but when you run Eclipse, let's see. Let's hop into Eclipse. There's this thing called a workspace, right? Which, when you first start Eclipse, it asks you what workspace you want to use, and it's really just a directory. But if I say switch workspace, it'll show me my current workspace, right? Which I set up to this weird, crazy name. But you know, if you just remember what workspace you used when you started running Eclipse for PA4, it should be in there. So my suggestion would be take those files from Eclipse and push them over to the Linux server and make your tar file on the server, or whatever Linux machine you plan to use to do your testing. Because remember, your classes have to work as standalone classes. So I want to be able to just say Java and the name of your class file and have it go ahead and run the game. So you want to be doing that, you know, probably in a virtual box if you don't have a Linux machine. And so easy way to transfer files from Windows to a virtual box is to use FTP, right? So or WinSCP if you like, from Windows. Push those over to the Linux server and then pull them down from the Linux server, or set up, you know, a shared folder under Dropbox. And there's some videos from 224 that are on the video list that show you how to set up shared folders and stuff. So for me, this was my workspace, and all of my projects are sitting under there. And so if I go into one of these directories, there's a source directory, src, and my Java file should be sitting right under there. So tar cvf pa4.tar asterisk java, cvf, and pa4.tar should be my file. So what do? I make a new directory, copy my tar file into this new directory, tar xvf pa4.tar, compile my main program, try to execute it. I don't know what Painter does, but you know, if this was PA4, I'd run this to see if my dots game worked. I think this was just a drawing program. And I mentioned in PA4 you can run this stuff on the Linux machine, but it's a little tricky to do. So I can SFTP to, you know, normally it would be username at linuxengrcs.com, and it lets you do this file transfer. And I think there's some 224 documentation on this posted on Canvas for this course. But let's make a directory called test, and let's go into test, and let's just put my Java files over there. So now if I hop on the Linux server, I can go into test, and there's my Java files. I can compile my main program, and it gives me my two class files. If I try to run this, it's not going to work. I'm going to get a message that talks about not having an X11 display. And that's actually a good sign, right? If I got a message about no such class or something like that, that tells me there's a problem with you know, some class file that I'm missing or something like that. This is saying basically it's ready to execute, but I don't have a display, and the code in this Java class is trying to do some display for me. And so that gives you a bit of confidence that your code is doing the right thing. But if you really want to test this on the server, you can do a -x, uppercase X flag. Let's see if this works. And then run your Java main, and this will be really slow, but it will eventually open up a window on my laptop and do its thing. Shouldn't be this slow, but sometimes it's really slow. But what you're doing is you're executing commands on this other machine, which I think is in Pennsylvania, and that command is trying to open up a JFrame, right, and track mouse motions. Well, the machine this is sitting on the other side of the country knows nothing about my mouse, right? It's an SSH connection. All it knows about is, ASCII characters being sent. But there's a protocol running underneath that, which is opened up when I say -x, which says, hey, I'm going to send you commands that ask you to do some drawing. And you can send me information that has to do with mouse activity and keyboard activity and so on. Yeah, it's taking a really long time. But theoretically, this will work. But, your better test is just to run it on a Linux system, run Linux in a virtual box, and make sure it works as a standalone, and it should be fine. And I'm not actually going to test this on the server because, slow execution. So I'm just going to test it on my system using Java 11 under Linux. I might just let that run in the background, see if it ever does anything. All right, so PA5. All right, so you've seen the behavior of this program. So let's go through that in some more specific detail. So the basic behavior of the dots game is the same as PA4, as far as moving and scoring, completing boxes, switching turns, and so on and so forth. So everything from PA4 applies here as far as gameplay and such. So I want I'm giving you some specific requirements here. Largely to make it possible for me to test, everybody's program without having to spend an hour learning how to use their program. So you need a pair of radio buttons, right? And we can play with those in Eclipse later and see how to set those up. But radio buttons are, sets of buttons where you can only press one at a time. So for us, we're choosing, do you want to be the client or the server? And only one of those is a valid choice at any moment. You're either going to be the client who's connecting to a server, or you're going to be the server that the other player's connecting to. Hey, there's our pop-up. Cool. All right. So that is very slow. All right, so a pair of radio buttons for choosing, do you want to be the client or the server? One player is the server, the other is the client. Server is player 1 and goes first. Client is player 2 and goes second. Your main GUI is going to change depending on whether you're the client or the server. So if you are the server, I want to see a start button, which basically opens up what's going to be called a ServerSocket to allow other players to connect. And we're going to have to specify a port number. The port you're going to use is 1234. And we'll say what all this means when we talk about sockets and networking. If you're the server, player 2's text field should be set non-editable, so the person can't type in a name for player 2. When you hit the start button as player 1, if there's no name that's been entered for player 1, set a default name of server. This saves me from having to type in a default name again and again and again every time I run it. So if there's no name for player 1 when you hit start, if it's blank, just change it to server, or, fill it in with server by default and let the person change it if they want. All right, and then once you hit the start button, the turn is currently player 1's turn. On the client side, I want to see a new text field which says, hey, what's the machine you want to connect to? So I'm calling that host ID. And you can make a default value of localhost, which means I want to connect to the local machine, the same machine that I'm on right now. But somebody can type something different in there and it'll connect to a server on a different machine. The start button should be relabeled connect. right? Don't give me two buttons and have a start button that's bogus. Change the label on the start button from start to connect and have it act like a connect button. And when connect is hit, you go ahead and you create a thread, create a socket, connect to the server port 1234, change player 1 to be non-editable, and now you're connected to the server and it's player 1's turn, so you're waiting for player 1 to make a move. So this is all initialization that happens depending on whether you're the client or the server, and it runs up through and including when you hit the start button or the connect button. Alright, and once the game has started, once the connection has been established, the button changes to a quit button. So there's only one button on the whole game. Start for the client, connect for the server, and quit once the game is in progress. And you're not required to play the game again once it ends, so if the quit button is hit or if the game ends, you can just exit. So connection lasts for a single game. And then basically, once you've started the game, once the client has hit connect, first thing you want to do is swap names. Right? I'm the server, you just connected to me, I'm going to send you my name, you're going to send me your name, so that each person can see, not only their own name, but the name of the other player. So do that name exchange once in the very beginning. And then basically all you have to do is share information about mouse clicks. And so here's some suggestions for this. And this is where you start to get more and more flexibility about how you actually implement this. But here's some suggestions. And if you implement using these suggestions, you'll actually be able to play your game with other people. Right? People outside your group. Somebody else can run their server and you can run your client, connect to their server and play games with them even though they've got a different version of the code that they wrote. So yeah, so if we standardize, which you don't have to do, but if we standardize, then you can, test with other people in the class and so on.
Have to start some kind of dots tournament.
Yeah, totally, right? The Dots Championship. And I have a student from last year who he went way out of the stratosphere with this. He made this so that any number of people could play simultaneously on the server, and it would round robin turns. And I think he just finished a Android development course at WSU, and for his final project he implemented NetDots. And the version he came up with uses the same protocol, and so you can actually run your version of NetDots, and you could play with his version on his phone as a server, and it all still works, which is kind of magical. And we're going to talk more about client server in a few minutes, and it really is kind of a sort of magic way that all this stuff works together. The fact that you can take almost any web browser and go to almost any server and pull down web pages, and it still works. It's standardization of protocols. So I'll describe a protocol that will work and will be pretty simple to implement that you're welcome to use for PA5. So we are going to want to use threads, right? And all the networked communication is going to want to happen in this separate thread. Because our main program, right, you click a mouse, something happens, you exit. You hit the start button, something happens, you exit, right? We don't have a loop in our PA4 that we can sit in and say, hey, have we gotten a message from the other player? And there's no really good place to put such a loop, because if we put that inside, a mouse listener, if after we hit a mouse and we repaint the screen, we start waiting for a network connection, well, we're hanging up inside an event handler, and we don't want to do that. If the other player is thinking about a move and we try to resize our window is going to look weird. We're going to get that, great Windows effect where you see the frame and it starts like echoing, and you move it and shrink it, and you kill time while you're waiting for the system to do something by doing art with your window frame. So all the network stuff is going to happen in a separate thread, right? So your GUI's not doing any looping, such as waiting for a message to arrive. So we're going to make a thread, we're going to call it start method, and its run method is going to execute in a separate thread, and it will handle all the networked communication. So the two programs move in lockstep with one another, right? They start, and at any given time, one game is waiting for the user to click a mouse, the other game is waiting for a message saying, hey, here's the mouse click. And then they switch. This player is going to be waiting to, I'm going to get in camera. This player is going to be waiting for a mouse click, and this player is going to be waiting for a message informing them of the mouse click. This player clicks the mouse, message comes across. Now this player is waiting for a mouse click, this one's waiting for a message. So they move in synchronization like that. And so if it's your turn, you eventually click the mouse, which brings you into your mouse listener. Make sure it's your turn. Update your data structures, your box array. Call paint. But then at the very end, you got to do one other thing. Send a message to the other player telling them where the mouse was clicked. And that's the only thing you got to do, right? Just that one extra step after the mouse click. Send a message, tell the other player. So imagine you were playing dots with someone on the phone, right? So you would sit there and you'd think about it, and eventually you'd say, okay, I'm drawing a line between, this dot and that dot. You do that. Well, all you have to do is tell the person on the phone, okay, I just drew a line between dot 17 and dot 20. And they would mimic that move on their piece of paper, and now they're going to think about what move to make, and you're just going to sit there and wait. So you're not going to allow mouse clicks, you're going to ignore them if they happen. But your thread is going to be sitting there waiting for a message saying, okay, I just clicked between box 20 and 22. And once you get that, all you have to do is call your old code that responded to a mouse event and tell it, hey, the other person just clicked between these at this XY coordinate, and the code you've already written for PA4 will do the right thing. It will draw a line in the right spot. If it completes a box, it will assign it to that other player, put their initial in there, leave it as their turn, and so on. So other than creating the network thread for doing the I/O through the network communication, you really only need to do two new things, right? When you click the mouse, you need to send a message to the other player to let them know. And when your thread receives information that a mouse click has occurred, it needs to run whatever code gets run when you click the mouse, because it's supposed to do the same thing as if the other player had taken control of your mouse and clicked somewhere. So you shouldn't have to rework PA4 a lot. It's really just adding a few more things on top of it. You don't need to deliberately, share information about whose turn it is, because you're both starting with the same understanding of whose turn it is to begin with. If it's player 1, it's your turn. If you're player 2, it's the other player's turn. And you're going to switch turns each time that a legal move is made and no box has been completed. Alright, so here's a suggestion for a network protocol. In the very beginning of the game, each person sends their name to the other player, and then waits for the other player to send their name. Right? So as soon as the connection is established, send a single line containing your name, and then read a single line and use that to learn what the other player's name is. And make sure you send your name before you wait for the other player's name. The order is important. Alright? So that's one type of message, and it only happens once in the very beginning. It's just one line where you send your name, you receive one line with the other player's name. The general type of message will be a pair of XY coordinates. So my suggestion is send the letter C space X coordinate space Y coordinate. So a single line that conveys the XY coordinates of a mouse click. When you receive this message, you can turn this into a pair of integers pretty easily. So there's a method in the string class called split. If I store this in a string and I say variable name dot split paren quote space quote, it will break this up wherever there are spaces and give me an array of strings. I can check that array, make sure its length is exactly 3. And if I take element 1, that should be the characters corresponding to this. I can run that through integer.parseInt, gives me the x coordinate as an integer. And then I can take array bracket 2, that should be the string of digits corresponding to this number, run that through integer.parseInt. That gives me the y coordinate as an integer. Now I've got the xy coordinates of where the other player clicked, and I can just run my mouse click code with that xy pair. So that's the second kind of message, a coordinate indicator C followed by a pair of integers. And the third message is just the letter Q, and that's a quit message. It means the other player has quit the game, or, you know, I'll send that if I quit the game, and when you get that, just shut everything down and exit. So pretty simple protocol, 3 possible messages. Yeah, go ahead.
Is there a class that Java has for network protocol stuff?
Yes.
Otherwise it'd be very hard to implement.
Yeah, so we're going to look at 2 classes, and we probably won't get to these today.
Question.
Yeah.
So things sent over this thread can only be strings?
They can be anything you want, but strings are a whole lot easier.
Are they? Okay.
Yeah.
Alright, sounds good.
So we're gonna probably next week talk about a pair of classes: socket and ServerSocket. We might get to these today. We'll try to spin up some code today. And we're going to use these with scanner and with print writer. And it's going to look just like, you know, when we read from standard in using scanner, or we read from a file using scanner, we can read from a network connection using scanner. And when we want to write to a file using print writer, we can write to a network connection using print writer. And it's going to look and feel almost the same, which is why strings are a really easy way to do this. But we could send, you know, binary information if we wanted. But if we send binary information, we can't really read that with a scanner that has next line, unless we decide we're going to end our binary information with a ASCII 10, and we're not going to have an ASCII 10 in that binary data. And so we would want to do some kind of raw output. We wouldn't use scanners and print writers. We'd use, you know, readers and writers and things like that. So that's a string-based simple messaging protocol, 3 types of messages. As with PA4, but even more so with PA5, there are a lot of ways to structure this, right? So these are suggestions, but if there's a different way that makes sense to you, right, you're welcome to do that. But I strongly recommend starting with PA4 and then adding this extra layer on top of it. I'll be testing your code against itself. I won't try to run it with my client or my server. So you're writing both the client and the server. I'll test your client against your server. So as long as it's consistent within itself, that's fine. I'll run it as a standalone class, but you'll probably be developing an Eclipse. So I strongly recommend in Eclipse, get really comfortable with working with multiple versions of your program running at the same time. And we can dabble with that next week. But yeah, I have this feeling I'm about to dabble with it now, despite saying that. Because if you want to get going on this over the weekend or over the rest of this week, I don't want you to be impaired by this. So let's just go back to our Painter program. And, you know, we can run this and
just kidding.
yeah, what did I break?
You put a tar file in there?
Yeah, maybe that broke it.
2 of them actually, which is funky.
Well, yeah. Yeah, so don't create files in your eclipse path. You can copy them out of there, but I was being lazy. So let's try stuff to play with. Alright, so there's a good window, right? So while this is happening, right, I can hit the play button and get a second window popping up, right? And I have two different instances of this game running right now. And they don't interact with each other, of course, because we didn't do that. But so how do you work with this? Well, you know, hopefully you have a big enough window that you can show more than one thing at a time, or you don't mind, you know, switching between things. But I'd like to at least be able to see, you know, my different windows so I can click between them quickly, instead of, you know, having them all hidden under here and having to do this kind of foolishness, right? So try to have those hidden. And then down here where it says consoles, I can choose which console I want to see. Well, I've got two instances of my program running, right? This one and this one. And I can switch to the second one over here, and now I'm seeing that output as opposed but this is switching back and forth based on which window is producing output. So I can come over here, and this button right here is open console. So I can create a new console view, and I can change this console to console 2, and this one is console 1. And then I think, oh, that's still switching on me though. That's a bummer. Okay. Well, there used to be a way to set this up. Come on. Alright, let's see if I can do this. Let's set this to console 1. And let's set this to console 2. Well, that's annoying. Swiping up to brushing my left AirPod. Excellent. Something. Oh, fun. Okay. Yeah, wireless zoom is even better. Okay, so I thought I had a really easy way to be able to set one of these to display one output console and the other to display a different output console, and that's apparently not working for me right now. But it used to be.
Same process, so they're the same console site.
Yeah, except I mean, I can close one, and the other one still persists.
Well, now the other one's open. Changed both of them. So.
Yeah, for some reason this one, when I run this, it seems to update both. Yeah, that's main 1.
They're both main 1.
They're both main 1, yeah.
Now it might be different.
No, it's red
You
herring.
switched them back the second you put you noticed that?
Yeah. Okay, so I'm being goofy on something here, but there's a way to do this. Mess around with it, and I'll mess around with it and see if you can find it. But figure out something, right? Worst case, you can run with a single console and get in the habit of coming over here and just switching to, you know, whichever view you want. But try to make this efficient for you, right? So I put a note in here saying, you know, you might end up running your program, you know, a few hundred times in the course of developing it and finishing it, and you don't want to, you know, be doing what you just saw me doing every time that you want to run your program and check the output, right? So figure out what works for your setup, whether you open 2 consoles, whether you run 2 instances of Eclipse, whether you run one of these from the command line, whether you run both of these from the command line. Once you have your J-frame set up and you have your radio buttons and so on and so forth, which is probably the first thing you want to get going, you can kind of leave Eclipse, right? And you can just run these from the command line. And that's your cleanest solution, right? Just run Java twice and do it from 2 different windows, and now you've got, you know, console output in each window. You can close one window and rerun it and so on and so forth. So find something that's not going to impair your productivity. Right, so try to develop a streamlined method of running and managing your program instances. So grading, you can read the rubric, right? Downloadable, compilable files get you 15 points. Drawing the basic field gets you another 15. Having the client server button change the GUI as required, that's 10 points. Establishing the initial network connection is another 10. Swapping your names in the beginning is another 10. So you've got 60 points without any gameplay, just by designing the GUI and doing that initial network exchange. And then swapping mouse clicks and responding correctly is 20 points. Correctly tracking whose turn it is another 10. And then having the exit button or the quit button work correctly is your final 10. Main method has to be called, has to be in a class called net.dot. So net.java will be the main class. Take all of your .java files, put them in a tar file, upload to Canvas. Use the default package, make sure your code works with just a Java command, and you're good to go. All right, we've got about 20 minutes. Let me start with some actual Java code. And let me start with the ServerSocket class. And this will just be intended to give you some stuff to start using as you develop. Sockets are one of these things, once you sort of understand the basic setup, you have a couple of sample programs, it's pretty easy to just start tweaking the code and make it do what you want. All right, so what is a server socket? The basic setup here is we're trying to communicate from one machine to another. And so we're going to create a pair of communication points that will be linked together, possibly from one process on my machine to another, possibly from a process on my machine through the network to a process on a machine in Germany, right? Or in the space station orbiting. And so these are networked communications. And these communication points that we use, these are called sockets. And so a socket is I don't know how you want to think of it, it's the end of a pipe basically, where the pipe can, you know, extend through a network, right? Possibly the internet. And so if I want to send information from one point to another, I create a socket here, I create a socket here, and I connect them somehow. And now this socket can look like, you know, something like a print writer. And if I write into this socket, and I have something like a scanner connected to this other socket, I can read from this socket whatever was written into that socket. So it creates a networked connection that we can treat the same way we treat standard in, standard out, or files to send things in and read things out. And so for all of the times that we're going to connect a pair of sockets together, we're going to use what's called a client-server model. And a client-server model is just the notion that there's one socket that sort of receives connections from the other socket. So our typical setup will be, we'll have a server with some kind of socket down here, and this might be, this might be your Apache web server. And so when somebody runs their browser and they want to get a web page from linuxengrcs.com, the client creates a socket and connects it to the server. And now I can send whatever information I want to the server, such as a GET message. I can say, hey, fetch this page, and the server can send information back to me, and my browser program over here can display it. So these communications begin with the creation of a server socket, and then the clients can create a client socket, which is just called a socket, connect it to the server socket, and then do two-way communication. So ServerSocket is super easy to construct. We construct it with basically an address. Because on a typical machine there may be, a few hundred different sockets that somebody can connect to, and we have to identify these. So my socket for serving up web pages has an address of 80 if it's insecure, or maybe 8080 if it's a secure HTTPS. My mail server that receives requests to deliver mail to people on my machine has an address of 25. My FTP server for sending files back and forth has an address of 23. My SSH server that people connect to when they want to log in securely has an address of 22. So yeah, plugging a cable into, like an Ethernet cable into, plug one end into your router and the other end into the back of your PC, that's basically like a socketed connection. So there'd be a socket on each end, and the Ethernet cable is this sort of ethereal combination of connections that we call the internet that pass information from one point to another. All right, so on typical Linux machine, so here's all the active connections I have running on my machine right now, and we're mostly interested in these TCP connections. So TCP/IP is the protocol that sits underneath these socketed connections, and it's an old protocol. I think it was developed in the 70s. We can look at that later. But these are all the TCP connections sitting on my machine right now. And these are machines that are connecting to my machine. So my machine is called Nitro. I can swipe through all of that by saying, show me the numbers of all of these connections. So this is my local machine's IP address. This is an IP address of another machine that I'm connected to. And these things after them, these are these local addresses, 22 for SSH, 8080 for a web server, and so on. These are called port numbers. So a port number is basically an address that identifies a socket. And so for a PA5, the socket you're going to create to allow another player to connect to you is going to have the address 1234. So that's going to be hardwired. And that's the unique address we're using for this particular game. If you're running a Minecraft server, you have a different address, 14585 or something like that. So we're going to use a socket with address 1234. And so this ServerSocket class, you can construct a ServerSocket by giving it a port number. And once you do that, you can run a method called accept. And accept basically says, hey, wait for somebody to try to make a connection to me.
Can the length of a port number be different based on where it's connecting to?
So port numbers are 16-bit entities. And they go from 0 up to, I don't know if it's 32 or 64K. And the first 256 of them, I believe, are reserved. You have to have root access to set up a port number lower than, I think, 256.
What are they reserved for?
Well, if you look at etc/services, you can see sort of the standard port numbers. So port 13 was daytime. That used to be a port you could hit on a machine and it would tell you what time it was. Most of these are disabled now. 21 is for file transfers. 22, that's your secure shell, SSH remote login protocol. So every machine that you can log into, every Linux machine you can log into has a process running with a socket somewhere with a port number of 22 waiting for connections. 23 was the insecure version of logging in that's not encrypted. But if you had a telnet server, it would listen on port 23 and you could send over a username and a password and log in. But this was unencrypted, so anybody who was sniffing the network could see your username and password being sent. Right? So certainly if this stuff is wireless, but you know, back when it was just a plain old cable, you could tap into that cable and see the bits being sent. And if somebody's sending in you know, their username and password as ASCII characters, it's easy to pick those up. I did this accidentally in my first industry job. We were trying to set up a network, and I was playing around with the router, and I put it in a particular mode where it just sniffed the network and showed me everything. And I saw my coworker's username and password come across my screen. So I went over and told her, hey, you should change your password. So 25, that's a simple mail transfer protocol. So that's the old mail client. This is another time server, and so on and so forth. Who is? There's a finger protocol at 79 that shows you who's logged into the system. There's our old insecure web page, and so on and so forth. So all of these lower numbered ports, these are reserved, and you need root access to use those. And then the higher number ones, it's kind of fair game, and there's understandings about what ports are going to be used for what. Nothing seems to use port 1, 2, 3, 4 much, and so we're going to pick on that for our NetDots game. But you know, it's possible that somebody else running on a system could be using the same port number. And so yeah, these are 16 bits. So so yeah, some comments in chat, right? So when you start playing around with networks, you're potentially getting out of the sandbox of, you know, your own home or our Linux server, and it's sometimes easy to do things that will get people upset. For example, we're going to learn how to write a program that connects to a remote machine. Well, we could, you know, modify that program and say, hey, let's see if there is a socket with address 1, with port 1, or a socket with port 2, or a socket with port 3. And it's really, really easy to invent the concept of a port sniffer that looks at a machine and tries to find out which ports have sockets on it. And that's a cool thing to wonder. And, you know, one of the first things I did when I was playing with this was, hey, I wonder what other ports are available, and so I wrote a port sniffer, right? Well, this was, you know, in the 80s, nobody cared about this. But today, if you go to somebody else's machine and you start trying to access the different ports, there's a good chance there's security software that will say, hey, somebody's running a port sniffer, and we'll grab your IP address and, you know, generate a report for someone. probably not going to cause any issues, but it's just something to be aware of, that this is basically the stuff that lets you start talking to other machines. And even if those other machines are well maintained and don't let you accidentally come in and do damage, you can still be doing things that get attention. Or, you know, if you write a program that repeatedly tries to connect to a port on, you know, Google's machine, Google's server, and you're developing this program and it keeps hanging up and you keep exiting, but you're not actually exiting, you're just leaving your program running, you're doing a denial of service attack, right? Inadvertently, you're hitting their server with repeated requests to connect. That's a denial of service technique. So you want to be just a little bit careful with this, right? And, you know, if you're connecting to localhost, it's your own machine, nothing to worry about. If you're connecting to the Linux server and something weird happens, right, the only person who's going to notice is me, and I'll deal with it, and you know, I'll let you know, hey, by the way, your process was still running. But just something to keep in mind. All right, well, we've only got like 5 minutes to do a server socket. That's not a lot of time, but let's do something. Let's make a new server socket on port 1234. And let's accept a connection and let's just say connection received, and we're not going to do anything else because we've only got 4 minutes left. Alright, so server sockets I need to import from java.net. And I'm going to have to throw some try catches in here. Right, so on the accept and on the construction, I might get an exception. So I'm just going to throw a big try catch around all of this. Alright, so not a whole lot going on in here other than we're creating a server socket and we're accepting a connection. Alright, so not terribly interesting. But let's go ahead and compile this. So let's go ahead and run this. And so this is presumably hanging out waiting for a connection on port 1234. So if I do my netstat and I do the N for numeric and I look for port 1234, guess what? There's Well, that's not what I expected. All right, I don't have a 1234, but let me try this anyway. So I'm going to use a telnet program. Telnet is a general purpose client. It's not secure, but I'm just on a local machine. I'm not sending passwords. So I'm going to use telnet. I'm going to say I want to connect to my local host and I want to connect to port 1234. And as soon as I do that, my Java program comes back from the call to accept and says, hey, connection received. Now my Java program exited at that point. It just, hit the end of my method. But at that point, I could open, say, a scanner. I could construct a scanner with the socket that came back from the call to accept. And I could say, while scanner has next line, get the next line printed out. And my telnet program would let me type. And every time I type something and hit enter, I would see it come out here. So we've got to have more time, obviously, to play around with this. So we'll start with that next week. PA5, you should have enough information to start thinking about how you're going to hook it up, reworking the GUI, right? Because some of that is mechanics before you even start doing the networking, the radio buttons, the GUI, and so on. We'll go through radio buttons Monday. And then next week we'll start taking apart sockets more carefully, and we'll see what exactly the server socket is doing, what the accept method returns, and then we'll play around with making the client side, creating a socket, connecting it to a server socket, and then we'll start passing information back and forth, and that will give us some prototype code to work with for PA5. So PA5, you got 2 weeks from Friday, so you've got about 2.5 weeks from now. So plenty of time for that. But you can start thinking about it once PA4 is done. That's all I got today. So have a good afternoon. If I don't see you in office hours, have a great weekend. I'll catch everybody next time. Thanks.
Thank you. Have a good day.
You too.
This networking stuff is kind of scared me a bit.
Say what?
This networking stuff kind of scared me a little bit because somebody can mess up and create a lot of damage.
Yeah, so you really can't do damage, right? So most machines should be well run, and so you have to work pretty hard to actually be a nuisance, networking wise. And unless you deliberately do something like create a socket. And try to bind it to google.com or clark.edu or something like that, right? You're just going to be working on your own machine. And worst case, what will usually happen is you'll run your program and then you'll try to run it again and it'll say ports in use, right? And that's the biggest inconvenience because then you have to shut down the thing that was running. But I just wanted to mention, because I know some people in the class do, take this stuff and run pretty deeply with it, or they've done it in other languages and they want to try it in Java and so on. And if you start trying to do things like let's try to track how many ports are in use on this machine across time. That's stuff that someone could be doing if they were trying to be malicious, and so some systems will look for that. But everything we do for PA5, all the examples I do in this class are just going to be on our local machine for the most part. So nothing to worry about.
Okay.
Yeah.
I remember when I was listening to Minecraft server, if I were to create a port and not shut it down or stop it, if I were to run it again, it would say port in use.
Yeah, exactly.
So to kind of understand the trick behind it, in order to shut it down, I have to go into some kind of networking settings and shut it down of some sort.
So when you're running a Minecraft server, right, if you say stop as a server command or /stop, that does a number of things. It saves your chunks and so on and so forth, but it also closes that socket that's listening for connections. And once that socket is closed, then if you try to rerun the server, that port's available. But if you don't shut that down and close that socket, then the particular port number associated with the Minecraft server is already in use. And you can only have one process using a particular server socket at a time. And so if you try to run it again while the first one's running, it'll say, hey, that socket's in use, or that port's in use.
Okay, that makes sense.
Yeah, and we'll... Go ahead.
I was going to say, this kind of makes me want to learn more about networking when I go to university.
Yeah.
But I'm assuming that I don't know if I'm not going to web development, but I think learning networking is pretty useful, especially if I want to send somebody else data or
Definitely.
something like that.
Yeah.
I think it's a pretty cool skill to learn.
It is, and in a system programming course, you'll do all of this stuff from C usually, which is a much lower level, and so you deal with a lot more of the details. But then you can also take networking courses or security courses where you'd play around a lot more with this at different levels. And it's the whole client server model, which we're going to talk about separately next week, is a really useful tool to have for a variety of things. For example, when you have a printer on your system and it's being shared by multiple people, there's a client server model in use there. And the print server is listening to one socket, and when somebody wants to print something, they don't talk to the printer directly, they talk to the print server. And the print server says, hold on, I'm printing something right now. Or it says, okay, tell me what you want to print and I'll get to it later, and it saves it in memory or disk. And then when it discovers the printer's free because it's finished its last job, it'll take the next job and send that out. Or you send a job with high priority, it'll say, okay, I'm going to print this one next, and it puts it ahead in the queue and so on. And that's all client-server stuff, and you could wire that up yourself using sockets.
All right, cool. Looking forward to seeing that next week.
Awesome.
All right, thanks. Good.
All right, have a good one. Catch you later.
Yeah.
All right, bye.